Section 6.2 is trigonometric functions of an acute angle. That's an angle between 0 and pi over 2. What it means to be an angle between 0 and pi over 2 is that that angle could be the interior angle of a right triangle. And so this is the trig functions that a lot of students initially learn in high school classes that are defined entirely in terms of a right triangle. And then from here, in future sections, we'll build on this to get to expand the trigonometric functions to all real numbers. So we start with right triangle, and the hypotenuse I've marked there, and some angle theta. So the hypotenuse, of course, is always opposite the 90-degree angle. And we have these labels that we commonly use when we're talking about this. By opposite side, I'll mean the side opposite the angle that we're talking about, which is theta in this case. The adjacent side is marked here in the diagram. It's next to the angle. It's not the hypotenuse, though. So these are, by side, we really mean the legs. When we refer to the hypotenuse, we'll just call it the hypotenuse. Okay, so we define 6 different trig functions. These are called the elliptic trigonometric functions. For short, we usually just say trig functions. And this is for angles between 0 and pi over 2. So sine function, S-I-N-E, we abbreviate it as S-I-N. All of the trig functions have 3-letter abbreviations. At least all of the elliptic ones do. So sine theta is, by definition, would be the opposite over the hypotenuse. Now, this is going to be the same no matter how big the triangle is, as long as that angle is the same, because of similar triangles, which we did in a previous section. So cosine, written out as C-O-S-I-N-E, shorthand is C-O-S. Cosine of theta is the adjacent side over the hypotenuse. What we really mean there is the length of the adjacent side over the length of the hypotenuse. Okay, so sine, opposite over hypotenuse, cosine, adjacent over hypotenuse. It's very important that you memorize all these. So tangent is opposite over adjacent, which is really just rise over run for the slope of the hypotenuse. If you think about it that way, if that helps. So notice the hypotenuse is not in that formula for tangent theta. It's opposite over adjacent. It's also sine theta over cosine theta. You can see if you take sine theta, divide by cosine theta, means multiply by the reciprocal of cosine theta. You'll see the hypotenuses cancel out. Hypotenuses? I don't actually know what the plural of hypotenuse is. Hypotenusae? Anyway, I need to look that up. Opposite over adjacent is a tangent, and we very often use it in the form sine theta over cosine theta. It's very handy to know what all the trig functions are in terms of sine and cosine, because then you can figure out what the formulas are for them from the sine and cosine one. So there's a cosecant, which we abbreviate CSC, cosecant of theta is hypotenuse over the opposite side. So the length of the hypotenuse over the length of the opposite side. So these are going to be numbers larger than 1 because a hypotenuse of a right triangle is always the largest side. Right? Where the sine theta and cosine theta will be magnitude less than 1. It'll be between 1 and minus 1 because a hypotenuse, again, is larger than the adjacent side and it's larger than the opposite side. So anyway, cosecant, hypotenuse over opposite. I usually remember it as just 1 over sine theta. Cosecant is 1 over sine theta. And so I just take the formula for the sine theta, which is opposite over hypotenuse, and just flip it upside down. You get hypotenuse over opposite. That way it's just less memorizing. You have to know cosecant theta is 1 over sine theta. And so memorizing the opposite over hypotenuse, hypotenuse over opposite. You can skip that if you know that cosecant is 1 over sine. Okay, so secant, SEC, it's abbreviated. Secant of theta, so secant is the name of the function here. Secant of theta is hypotenuse over adjacent, which is 1 over the cosine of theta. So notice cosecant is 1 over sine theta. Secant is 1 over cosine theta. So the reciprocal, if one has the then its reciprocal doesn't, and vice versa. No, actually, it's actually saying the same thing. Okay, then finally, cotangent is 1 over tangent. So it's going to be adjacent over opposite. Kind of like run over rise. 1 over tangent theta. Remember, tangent theta was sine theta over cosine theta. So cotangent theta is cosine theta over sine theta. These are all formulas that you should know. And so just kind of keep going over them until you have them down if you don't know them from a previous course. They're very important.